Now, today's topic is electric resistance. Electric resistance is actually the obstruction posed by the conductor to the flow of current. So what is resistance? It is the obstruction posed by the conductor to the flow of current, and if mathematically we write it, it is given by the ratio of potential difference upon the current, right? So it is the obstruction possessed by, so whatever is the when the current is allowed to pass through a conductor, actually what happens, the free electron suffers frequent collision with the ions or atoms of the conductor. Due to these collisions, their motion is opposed, right? Now let us explain this formula. Here we are having conductor, and let a potential difference V is applied across the ends of the conductor, due to which the current flows through it. But while flowing, the electrons will suffer frequent collisions with the ions or atoms of the conductor. Due to this collision, their motion is obstructed, and that obstruction is called the resistance. So if we want to write the basic cause of resistance is the frequent collision of free electrons with ions or atoms of the conductor. Now let us write the units of resistance. We know that resistance is measured in ohm, and voltage, potential difference is measured in 1 volt, and upon current is measured in ampere. So 1 ohm is equal to 1 volt per ampere, and we can define the resistance possessed by a conductor is said to be 1 ohm when, on applying a potential difference of 1 volt, a current of 1 ampere flows through it. Right? Any unit definition can be written as by putting unity to all the physical quantities, all the units. So resistance is said to be 1 volt. When it is said to be 1 volt, when potential difference of 1 volt is applied, and when we know that potential difference is applied, what will happen? The current flows. How much current flows? 1 ampere of current flows through the circuit. Now to write the dimension formulas for R. Dimension formulas, in that case, we know that V is equal to work done per unit charge. Work done is measured at force into distance, so mL2 T minus 2. Charge is Q. Q is coulomb, or we can write also I is equal to Q by T. So Q is equal to IT, or that is equal to AT. So writing this is AT. Now we have to write V upon I. I is measured as A, in measuring A. So R is equal to M1 L2, T that goes up becomes T minus 3 and A minus 2. So this is the dimension formula for the resistance. So we have studied the basic causes as well as the dimension formulas for the resistance. Now let us discuss about the electrical resistance and of the specific resistivity. We have studied here that R is equal to V by I. Now we will study how the resistance depends upon the length and on the area or on the nature of the material. That will be discussed in our next slide.